Is it working? Can y'all hear me out there in Zoom land? Anybody? It looks like it's working.
Yeah, we can hear you.
Sweet. The good old unplug, replug. All right. All right. So there's Lily for Halloween. It was awesome. I hope y'all had a great Halloween too. Lots of candy. Now all she wants to do is eat candy. I'm still trying to figure out these terrible twosies things. Like the day she turned 2 years old, it's like just cry over nothing. And it's like, you want a popsicle? It's like, yeah. Just immediately stops, totally normal. The manipulation, it's like they finally got smart enough to know, oh, I can manipulate. And that's like their number one task every second of the day is to figure out how to use that tool to their ultimate advantage. Of course, my ultimate tool is like just not even paying attention, right? Totally ignore bad behavior, right? Of course, sometimes I can't help but laugh at her. Like the last year, anytime she'd cry and I knew it was fake, it's like, you want me to cry with you? I'll cry with you. No. And then she'd stop. That always worked. But now it's like, that doesn't work anymore. She just keeps crying through it. And I'll figure it out though. All right. So we left off doing some antiderivatives last time. I think, let's do this checkpoint here to kind of refresh our brain. Make the desk shorter again. This feels different. I don't know. All right, so we're doing antiderivatives. Remember, you could pull a constant out front, right? And remember, because the derivative of e to the x is just e to the x, the antiderivative of e to the x is going to be e to the x. But remember, you have to throw on a constant. We typically use c for the word constant, which later on is going to be troublesome because we're going to use c for a cost function. So we're going to use the same c for two different things, but it should be obvious from the situation, right? Because the derivative of a constant is 0, right? So this is all the possible antiderivatives for this guy. Here, we have to have e to the 5x again, but we have to divide by 5 because when you take the derivative of this, you're going to get a 5, and we want it to cancel with that one on the bottom because there's no 5 over here. And we have to add our constant, right? I'm going to forget to add the constant over and over again and have to go back and add it. So that's a common occurrence. This one, we can take these and turn it into two antiderivatives, right? Right, that difference, you can just bust it into two. So the dx shows twice, right? You have these parentheses here, you can distribute it. So this one is going to be e to the 4x over 4. And we have our minus 4 here. And then e to the x is just going to be e to the x and then plus a constant. Y'all remember this stuff from last time? Derivatives backwards. Cool. So this guy, we could pull the 11 out. So we have a minus 11. We're going to need an e to the minus x. And this is really a minus 1 here, right? So we would want to divide by a minus 1. But that's the same thing as multiplying by a minus, isn't it? So if you check your work, the derivative of that is going to be e to the minus x, and then you're going to get times a minus. And that's what we have over here, right? So that's what we have. That's kind of a recap from last time. Y'all are good at the power rule. So here we finally get to this guy. All right. So y'all remember that, right? The integral of x squared would be x cubed over 3, right? Or the integral of x to the minus 2 would be x to the minus 1, right? But there's this issue whenever you have x to the minus 1. If you try to use that power rule, you'd be like, okay, add 1 to the exponent and then divide by the exponent, right? You can't divide by 0, right? So remember, the derivative of natural log was 1 over x, okay? So the integral of 1 over x is going to be natural log. That's what they're saying here. The integral of 1 over x is natural log, and that's because the derivative of natural log is 1 over x. Does that make sense? All right. Now we're going to do a few examples. We'll redo that over and over and over again. Hammer it home. So these are just one-liners here. Right? This one, you can pull the 4 out front. Then you have the 1 over x. So we have the 4. Integral of 1 over x is natural log, and then add plus a constant. This dude we can break into two different ones. This is a minus 5 integral of 1 over x. And then we have dx. And then the integral of e to the minus 2x dx. So this one is just the minus 5, boop, and then you have the natural log. This one here, you have the e to the minus 2x, but you have to divide by a minus 2, and then you have a plus a constant. Okay. Now let's do this checkpoint here. Where this desk is lower. Did I get taller? All right, this guy, we can pull out the minus 9. We still have a 1 over x. So this is just minus 9 natural log of x plus a constant. This guy, we pull out the 8 and pull out the minus 3. So we have 8. We have e to the 4x, and we have to divide by 4. Because again, when you take the derivative of that, you're going to multiply by the 4, and you want it to cancel with that one. Minus 3, and then the 1 over x gives us a natural log plus a constant. Of course, we would turn this into a 2, right? All right, applications. So we keep adding this constant in, right? In applications, we can determine what the constant is, right? Because this is an infinite number of equations, right? Change C. C could be anything, right? So this is really an infinite number of antiderivatives, right? In application, we want 1. So with a little bit of data, we can figure out what the constant is, right? So here, they tell us what ds dx is, right? So think about it this way. If I multiply both sides by dx, all right, I just take this and move it over here, multiply both sides, right? And then if I integrate both sides, well, s is the integral of ds, right? The derivative and the integral are opposites of one another. Does that make sense, how we just set that up? So s is the integral of s prime, basically. How can I do that? Now I'll just leave it like that. I don't want to throw the prime notation in there. So all we have to do is integrate. So the integral of this stuff, we would have minus 10, the power rule, right? Add 1 to the exponent, divide by the exponent, right? The opposite of what we used to do and in the opposite order. And then we have 162 x to the first becomes an x squared over 2. And we have minus 34x and then plus a constant. So this is what s is, s of x. Now they tell us that in year 0, there were 738 million cell phones. So in year 0, it would be 738, but this is s of x, right? So I would have all of this, but replace x with 0. So all of that goes away, and we just have c. So what they're saying here is 738 is what our constant is. Does that make sense? So now that we know what the constant is, you just replace that. That's 738. Now you know what the actual antiderivative is instead of the whole class of them. So now we're going to do this over and over and over again. So stick. So yeah, there's S of X. They replace C. Oh, here's a checkpoint. I'm gonna miss the checkpoint. S prime and S of 4. Okay, well, S is the integral of S prime dx because it's with respect to x. So this is the integral of 7x plus 3, okay, which would be 7x squared over 2 plus 3x plus a constant. All right, so this is what S of x is. It's something like that, right? But the fact that we have this information, we could say, okay, well, S of 4 would be 7 times 4 squared over 2 plus 3 times 4 plus a constant. Let's see, what is this? This is 16 divided by 2 would be 8. What's 8 times 7? 56? 56 and 12 is 68. And they said that S of 4 is equal to 76. So this is 76. So therefore, C is whatever that is, 8. C is 8. So this is 8. Easy enough, 2 steps. Antiderivative, plug in the data, figure out what C is. Okay. Let's look at this one here. Dang it. All right, remember marginal revenue? That's the derivative of the revenue, right? Well, if we have R prime, we can figure out what R is, right? R is going to be the integral of R prime. So this is the integral of 40. Since we're dividing, let's just make the exponent negative. And I need these parentheses in here, right? So there's R prime dx, so I get 40 e to the minus 0.05x divided by minus 0.05, and then 10x, and then plus a constant. Let's simplify this. 40 divided by 0.05, I think, is 200. So this is R of x, looks something like that. We don't know what the C is, do we? I guess they don't give us any extra information, but if X is the number of units you've sold, right? So if you sell 0 units, wouldn't you expect a revenue of 0, right? So let's make an assumption. Let's assume that R of 0 equals 0, right? Because if you don't sell anything, you have no revenue. That makes sense to me, right? So we could figure out what C is. So R of 0, though, would just be negative 200 e to the 0 plus 10 times 0 plus a constant. So this is 0, this is 1. This is negative 200 plus C, so therefore, oh, and this should be 0, so therefore C is 200. So replace that with a 200. Now we've fixed it so that if you don't sell anything, your revenue is 0. Does that make sense? Okay. I don't know if we're supposed to do that or not. They just said find the revenue function. Well, if you have a C there, that's a class of revenue functions, but what is the revenue function? I guess that's how we do that, right? Makes sense to me business-wise anyways. Let's see, what did they get? They got 800 here. Maybe they did it. Either I did my math wrong or something. Let's see. Yeah, I did. I divided wrong. This is not 200, it's 800. So C should be 800 there. Right? Did my arithmetic wrong in my head. But our assumption was correct. Right? All right. And here's part B. Now, we're going to use the letter capital C for the cost function, but we're also using capital C for a constant. Two completely different C's. Does this make sense? We're recycling, right? So if this is C prime and we want to know what C is, find the cost. So we'd have C is the integral of C prime. So we have, if I wrote this out, I would write this the 9 on the outside. This 1 over the 4th root, so it's negative because we're dividing, and the 4th root means that. So let's see, I need to add 1 to the exponent and divide by that exponent. So C of x, if I fix this, 9 divided by 3 is 3, multiplied by 4 is 12. All right, so that's our C of x, but they want to know, well, they give us the fact that 16 units is 200 bucks. So C of 16 would be 12 times 16 to the 3/4, right? Should be $200. Okay, well, let's see. What is 16 to the 3/4? 16 to the 3/4 would be 16 to the 1/4 cubed, but 16 is 2 to the 4th, all right? And an exponent to an exponent you multiply, so this is just 2 cubed, which is 8. So this is 12 times 8. And 12 times 8 is what, 96? Therefore, C would be 104. So, boop, this is 104. Or actually over here, 104. That's our cost function. Make sense so far? Same thing over and over again, right? Let's do it again. Oh, they switched to the letter D in here so that you wouldn't get confused, right? But, yeah, I mean, you could use any letter you want. We could use K. All right, oh, here's a checkpoint. Let's do this checkpoint. So here's C prime. We need to find what C is. All right, well, C is the integral of C prime. Is the integral of 2x cubed plus 6x minus 5 dx. So this would be 2x to the 4th over 4, 6. The x goes to x squared over 2. The 5 goes to 5x. We need a constant. Now we can simplify. 2 over 4 is a half. 6 over 2 is 3. So this is our C of x, and we need to find out what C is. The fixed cost is 800. What does that mean? Fixed cost. Remember, there's the variable cost. Go ahead. That should be C of 0 is 800. Yeah, the fixed cost. It's the upfront cost, right? The variable cost varies, and it depends on how many items you sell or make or whatever, right? The fixed cost is the setup cost. So knowing that, we could say, okay, C of 0, that all that would be 0, right? Right? So we get a bunch of zeros, 0 plus 0 plus 0 plus C should be 800. So therefore, C is 800. So we could just go up there and be like, boom, 800. No way, it's the wrong spot. Right here, boom, 800. That's our C of X. We're good? All right, let's look at another one. We'll do the same thing again. Example 10 here. The population of the southern region was 101 million at the start of the millennium. For the years 2000 to 2017, its growth rate is given by this function. find the function big F of t that gives the population. I don't like these big F's and little f's, right? Basically, the way they've set that up is that big F prime is little f, right? And why use F? This is a population. Why not use P of t and then tell me that P prime is this, right? This is the rate of growth of the population, but they want to use little f, right? I mean, it's so easy to turn that capital F into a capital P. I mean, it's so close, right? Then why not just call this P prime, all right? So find the population. Well, P is the integral of P prime, the integral of 1.212 e to the 0.012 t dt. This is 1.212 e to the 0.012 t, 0.012 t, plus a constant. And we could simplify, what is this, 101? 1.212 divided by 0.012, 101, yeah. 101 e to the 0.012 t. It's not like I'm doing this in my head. I remember it from the last class, although I should be able to do this in my head. The other teachers that teach this could do it in their head, but they were in number sense class when they're like in third grade. So I didn't get into math until I was like 25 years old. I have to use a calculator. All right, so here is our P of t, but we're going to use the fact, where is it? This one. At time 0, this means at time 0, the population was 101 million. So if we set that up, P of 0, P 101, if we made this 0, e to the 0 is just 1, right? So that tells us that C should be 0. We subtract 101 from both sides, right? This is e to the 0. So, boom, 0. So that's part A. Part B is probably predict to see what the population will be at some point in the future. So now we know what P of t is. Yeah, what is the population in the year 2023? Well, that's the time 23. This is the population at any given time. So just plug in 23 in for t, all right? We get 133 million. That's it. Wait, we also have checkpoint 9. Point number 9. Do this one. So here's another population growth rate. Again, I'm going to call this P prime. And that the population is 125 million in the year 0. Find P of t, find the population. So this is just like the last one. P is the integral of P prime. This is the integral of 5e to the 0.04 t dt. All right, which would be 5e to the 0.04 t divided by 0.04 plus a constant. And what is 5 divided by 0.04? 20 or something? 5 divided by 0.04? 125 e to the 0.04 t. This is our P of t. All right, and then we know this. We know that P of 0 is 125. And if we replace t with 0, this is just 1. So we have 125 equals 125 plus c. So again, c is 0. So P of t is just 125 e to the 0.04 t. They want to know what it is at year 20. Just plug in a 20, type that in your calculator, and you know the answer. So this section's pretty easy, right? All right. So I don't want to move on to the next section yet because in the last class, again, I didn't have my webcam, so the students couldn't hear me. So I promised them instead of moving on, we're going to work a bunch of these exercises. instead, and then we'll move to the next section on the next class. Might put us behind a little bit, but not that big of a deal. All right, so let's look at some of these. So here we'd have a 12. The x would become an x squared over 2, right? Plus a constant. Over here we'd have our 25. The r squared would have to be an r cubed over 3. Over here we still have our 8. The p to the third would become a p fourth over 4. Here we still have the 5. The t to the fifth becomes a t to the 6 over 6. The 105 stays. The integral of dx, right? The integral of dx, it's just x. This and this undo one another. You just get the x, right? Because the derivative of 105x is 105. Same thing here. And I got my constant. All right, so those are easy. Right, this next exam should be really easy. What is this one? You can break it up into 2, of course, right? So we have the 5, the z becomes a z squared over 2. We have a minus, and then the 1 dz. The integral of 1 dz is just z at a constant. This dude here, we have the 2. The m squared becomes an m cubed over 3. And then the 3dm just becomes a 3m. All right? This guy here would be z cubed over 3 minus 4 z squared over 2 plus 6z. Add the constant. Here we keep the 2. The y squared becomes a y cubed over 3. Keep the 10. The y becomes a y squared over 2. And then the 7 becomes a 7y. X cubed becomes an x to the 4th over 4. We have a minus 14. The x squared becomes an x cubed over 3. Keep the 22. The x becomes an x squared over 2. And the 8 becomes an 8x. They're easy, right? You can do these in your sleep. Let's look at some different ones here. Look at this one. Let's see. We keep the 6. T times t to the 1/2. What is that? That's t to the 3/2, isn't it? So we add 1. 3/2 plus 1 would be 5/2, right? And then we have a 3. This is t to the 1/4 here. So we would have t to the 5/4. And then plus a constant by the power rule. So like this guy here, we would have 10 u, add 1 to the exponent, divide by the exponent. U 5/2, add 1, I get 7/2, and then divide by the exponent plus a constant. These work the same way, right? We'd have a 24. This is x to the minus 3, right? We'd have to add 1, divide by the exponent. We have a minus 20. This is x to the minus 2. So if we add 1, and then divide by the exponent. So this would just be 20 over x if we simplified it. All right, let's look at some of these word problems. Well, we could do some of these down here. These look a little bit better. Some honorable mentions down here. Let's do like these two. All right, this one, I would simplify this. I would do that and then that separately, right? So this is 1/2 minus a third. So what is that? X to the 1/2 times x to the minus 1/3, right? That's what this is. And now we have to deal with fractions, right? So 1/2 is what, 3/6? and 1/3 is 2/6. So this is x to the 1/6. So this is just x to the 1/6. And then this is x to the minus 1/3. All right? Does that make sense? Just algebra here. So we add 1, that would become 7/6 divided by the exponent. Add 1 to 1/3, that gives us 2/3 divided by the exponent, add a constant. Same thing over here. This is that guy. 1 divided by that, that's z to the minus 1/3. And let's see, those would cancel out, right? Boop. So let's see, we add 1 to our exponent, divide by the exponent, and then 2 becomes 2dz, and then add our constant. Let's work some of these. Do like number 46 here. All right, the rate of change of the size of the crowd and people per hour at a certain theme park is given by P prime of T. So this is a rate of change of the population. All right, and T is 0 is opening the park at 8 a.m. Find P of T that gives the size of the crowd T hours after opening. Well, P is the integral of P prime, is the integral of 2800 minus 400t dt to be 2800t minus 400 t squared over 2 plus a constant. Or simplifying, we have this. This is our P of t. We need to find out what C is. We're going to assume, right? Assume that at time 0, we have 0 people in the park, right? So this would be 2800 times 0 minus 200 times 0 squared plus a constant. That's 0, that's 0. So therefore C is 0. So P of T is just this. When is the size of the crowd a maximum? Right? So this is A, right? B, the max happens when F prime or P prime is 0, right? That's where your critical points are at. Now it could be a minimum or a maximum. We already know the minimum is going to be 0 at time 0, right? So if we set this equal to 0, 2800 minus 400t, they've already given us P prime, right? P. So if we set that equal to 0, let's see, then T would be 2800 over 400, which is what, 7? So 7 hours after 8 a.m. 7 hours after 8 a.m. When is that? 3 p.m. That's when you're going to have the maximum, right? Again, this is a critical point, which could be a minimum or maximum, but we already know the minimum is at time 0 when the park is open, right? What is the size of the maximum crowd? Well, the maximum crowd occurs at t equals 7, max at t equals 7. So the population at time 7, this, but we replace t with 7. So what is 2800 times 7? That's 19,600, and then 200 times a 49, so 9,800. So this would be 9,800. Questions? Am I going too fast? Okay. Let's look at, say, 48 here. If the rate of excretion of a biochemical compound is given by f prime of t, the total amount excreted by time t in minutes is f of t. Find f of t. Okay, well, little f is the integral of f prime, integral of 0.1 e minus 0.01 t dt is 0.01 e to the minus 0.01 t divided by minus 0.01. If those would cancel, it's just negative e to the negative 0.01 t plus a constant. That's an expression. So that's part A. Now part B, if 0 units are excreted at time 0, how many units are excreted in 10 minutes? So they're saying at time 0 we get 0, but f of 0 would be negative e to the minus 0.01 times 0, which is this negative 1. Oh, I forgot my plus a constant. Plus a constant. So this is just minus 1 plus a constant. So if 0 is minus 1 plus a constant, then the constant has to be 1. So f of t equal to this plus 1. So for 10 minutes later, f of 10 would be negative e to the minus 0.01 times 10 plus 1. Or negative e 0.01 times 10 is what, 0.1? Whatever that is, plug it into your calculator, you get a number. Equals some number. Questions? Let's see if we can find a harder one. Find the cost function. These are just more integrals here. Easy. Oh, here's the answers to all the checkpoints. That's great. All right, let's look at, oh, we're going to run out of problems. Number 57, I guess. All right, the population of the U.S. was 326 million in the year 2017. So T equals 17 means P is 326. The projected growth rate can be approximated by this function. I'm going to call this P prime again. Okay. Where T equals 17 is year 2017. Find the function P of T that gives the projected population in year T. Round the constant C to the nearest integer. So P is the integral of P prime, is the integral of 66 over T, right, which would be 66. Since it's 1 over T, we have the natural log of T plus a constant, right? So the fact that P of 17 should be 326, but P of 17 would be 66 natural log of 17 plus a constant. That tells us that C is 326 minus 66 natural log of 17. See what that is. 326 minus 66 natural log of 17. Approximately 139.01. That's our C value. So find and interpret f of 47. F of 47 would be, oh, in this case, P, would be, where is their function? Here it is, P of T. It's be 66 natural log of 47 plus our constant, would be 66 after log of 47 plus 139.01 gives us approximately 393.12. So what does that mean? That means the population in year 2047 population is 393 million. Let's do one more. Recently, there are approximately 200 million licensed drivers in the U.S. 16-year-olds had 20 accidents per 100 drivers. That means a fifth of every 16-year-old had an accident that year. 1 out of 5 16-year-olds. The rate at which the number of accidents per 100 drivers changed as the driver's age increased was approximated by G of X. So this is a rate of change. All right, the rate at which the number of accidents increased. If it's an increase, why is it a negative number? That's my first question. Is that a negative number, or is that just a fraction? What is that? Yeah, that is a minus sign there. So, yeah, as the driver's age increases, the rate of accidents decreases. So, yeah, it makes sense. Find a function that gives the number of accidents per 100 drivers of age X years. Okay, well, if they use little g of X, let's use big G, right? Where big G prime is little g, right? So we need G would be the integral of little g negative 10.2 over X dx, negative 10.2 natural log of X plus a constant. So this is going to be our G, big G of X. And then we use, what was this, 20? So what is the X again? X age, all right, X is the age in years. So we know that at 16, we should have 20, right? How do we interpret this? 20 accidents per 100 drivers. The rate at which this change is 200 million. How can we say this? All right, if there's 200 million, well, they aren't all 16-year-olds. We don't know how many 16-year-olds. We just know that there was 20 accidents per 100. That means 1/5 of them, right? How do we get a number there? Because we have no idea how many 16-year-old drivers there are. The rate at which the number of accidents per 100 drivers. So this is just the rate of change overall. All right, this one's going to require some thought, right? So let's see. What is G? G, the ones that had accidents? Let's see. Yeah, so G would be the number of drivers that had accidents, right? So I want to say something like it's 1/5 of all the drivers, but this would not be right because that's only the 16-year-olds, right? Yeah. right? But that doesn't make any sense. Hold on. We can't use that. We have to use this. So the rate of change. So let's see. If we put in 16 here, so if we put in 16, that would tell us how the accidents changed from year 16 to year 17, right? So this is like big G prime. So this is the marginal accident rate. So if we plugged in a 16 here, see G, we looked at G prime of 16, this would be negative 10.2 over 16. That would be the rate of change of accidents from ages 16 to 17. And with that rate of change, we should get us a piece of information here. The rate at which the number of accidents per 100. Find, well, they just say find a function. They don't say find the function. Okay. Well, this is a function. So we might need more information. I think we should be able to squeeze some more information out of here to get the C though, by using this, right? That would be the rate of change from age 16 to age 17. Oh, well, let's look at the part B here. So this is part A, that's a function. Approximately how many accidents per 100 drivers did drivers of age 18, 20, 50, and 70? So to do this one, we do have to figure out what the C is. So let's see, how can we find out what C is? For part B, what is C? We're going to need it. And we're out of time. All right, I'll look at this. I'll look at this later, and we'll in the next class we'll figure out how to find out what C is. This is a good problem. All the rest of them were just basically, reflex. This is the only one that actually required any thought. All right, we are out of here, folks. Until next time.